Okay, guys, in this video, we're going to be looking at example 4, which are cube roots, and some of them will be perfect cubes, and some of them will be non-perfect cubes, but they all have variables. So we'll start off with the cube root of 27. We ask ourselves, is 27 a multiple of 3? Can I divide 27 by 3 evenly? You should have a list of the multiples of 3 all the way up to 3 times 10. 27 is on that list. 27 divided by 3 is 9. So we can say that the cube root of x to the 27th is equal to x to the 9th. Okay, perfect cube. Now we'll look at the cube root of 64m squared n to the 11th. We'll start off with separating it by its parts. So we have the cube root of 64 times the cube root of m squared times the cube root of n to the 11th. So we'll start off with the cube root of 64. 64 is on my list. The cube root of 64 is 4. Now we'll look at the cube root of m squared. Now here is an important rule. In order to take the cube root of a variable, the minimum exponent needs to be a 3. Think about it. If you're counting by threes, the first number that you say is 3, then 3, 6, 9. But the first number you say is 3. So if the exponent is less than 3, if it's a 1 or a 2, you cannot simplify it any farther. So this will just be the cube root of m squared. Now, n to the 11th is bigger than 3. And so 11 divided by 3 is not a whole number. So we need to find the largest multiple of 3, that is not greater than 11. So as I'm going up my multiples of 3, I have 3, 6, 9, 12. 12 is too big. So we're going to use 9. So we'll rewrite this as n to the 9th, and then times n, and we have to see what we have left over. To do that, we'll just do 11 minus 9, which is 2. So we can rewrite this as the cube root of n to the 9th times n squared, and the cube root of n to the 9th, 9 divided by 3 is 3. So we'll have n to the 3rd, and then what we pull out will be what we leave on the inside will be the cube root of n squared. So all together, we have n to the 3rd cube root of n squared. So all together for our final answer, this part right here, we can get rid of the multiplication signs. We'll put the outside pieces together. So the 4 and the n to the 3rd will go together. 4 n to the 3rd. And then we'll put the stuff that is inside the parentheses together. We have m squared and n squared. So we'll put those on the inside, m squared, n squared. And that will be our final answer. Okay? So that's non-perfect cubes. We'll look at part C here, and then we'll be done with this video. So we have 3 cube root, and we're going to separate the numbers from the variables. So 3 cube root of 40 times the cube root of w to the 16th. 40 is not a perfect cube, so we're going to divide it into its perfect cube factor. So I divide 40 by 2 and I get 20. The only perfect cube less than 20 is 8. 8 is a multiple of 40, so we're going to break this down into the cube root of 8 times 5. And that will leave us with the cube root of 8, which is 2, and the cube root of 5 will be left behind. Now we have the cube root of w to the 16th. Again, we're looking for the largest multiple of 5 that is less than 16. So 3, 6, 9, 12, 15. So we're going to do the cube root of w to the 15 times w. And again, we'll just do 16 minus 15 to get 1. That's what's left over. And now we can take 15 divided by 3 to get 5. That's what our new exponent's going to be. So this is going to be w to the 5th that will come out, and left on the inside will be the cube root of w. And that's going to be boxed in. So then we're going to look on the outside. We have the 2 on the outside, and we have the w to the 5th on the outside. So we'll have 2 w to the 5th. And then on the inside, we'll have 5 and w. So we'll have 5w on the inside. Guys, that's how you do non-perfect cubes. This is going to be the set of try it problems that I want you to give it a shot. And then if you have questions, please let me know in class. So go ahead and give those problems a try and let me know what you got. Okay, thanks. Bye.